Hello everyone, I'm Xiaojing. I'm from Shandong University. Today, my reported title is An Iterative Feedback Mechanism for Auto-Optimizing Software Resource Allocation in Multi-Tier Web Systems. This is the outline. Introduction, Workload Model, Iterative Feedback Mechanism, Experiment measurements, and conclusion. The first is introduction. With the growing popularity of web services that have been widely used in human lives, the quality of service has become an important requirement. How to guarantee and optimize the QoS is a hot topic. Recently, most of Internet applications that host web services are implemented by multi-tier architecture. For example, three-tier architecture, which consists of web server tier, application server tier, and database server tier. The design of the system architecture and the optimization of system parameters are critical to the QoS of these applications. Allocating appropriate hardware resources and proper software resources are two ways to optimize QoS. Meanwhile, dynamic workload is another critical challenge for QoS optimization. However, it is impossible to adjust hardware resources continuously in response to dynamic workload. Software resource allocation should be well studied accordingly. In our paper, there are two main contributions. Firstly, an iterative feedback mechanism is proposed to effectively handle dynamic workloads and meet the performance demands in multi-tier web systems. An reinforcement learning approach on optimizing software resource allocation is applied in this mechanism. Secondly, the semi-microprocess is used to model the dynamic workload and calculate the parameters, which can describe the workload more formally and improve the accuracy of model training. Next is workload model. In web systems, the workload can be modeled by microfunction in general, such as rubies. In this paper, we not only consider the user tasks, but also the impact of each task on each tier. Therefore, we extend the microfunction and establish the SMP model, which is able to capture more details and patterns in the workload and to provide much more accurate results of performance analysis. An example of SMP model is shown in Figure 1. Based on a given SMP, a n plus n matrix of transition probability can be represented as P, which Pij means the probability of jumping from page I to page J. Based on a series of formulae, we formalize the workload WL as follows. The detailed process is described in our paper. Next is iterative feedback mechanism. In this part, we describe the iterative feedback mechanism and optimization algorithm. This figure shows the iterative feedback mechanism. It includes three modules. In data collection and pre-processing module, input dataset is needed to train the software resource predictor. Each piece of input data consists of two parts. One part is the measurement data, including the software resource setting and the performance of the system, and the other part is the corresponding workload calculated after modeling the workload with the semi-micro process and parameter calculation. Dynamic workloads significantly influence the performance of multi-tier web systems. Therefore, it is important to model such workload to effectively evaluate the performance and ensure the accuracy of the training data. In SR Predictor module, it is used to predict software resource allocation and supplies this information to the resource allocator. It contains two components, a deep Q-learning network and an environment model of software resource allocation. The former is a deep Q-learning network for obtaining the changes in software resource allocation, and the latter provides rules for selecting software resource configurations while ensuring system performance. In Resource Allocator module, the new software resource allocation policy obtained by the SR Predictor replaces the previous outdated one. After this, as the system continues its operation with the new software resource setting, new workload and performance data are delivered to data collection and pre-processing module as measurements. At the core of the iterative feedback mechanism, SR Predictor is designed to drive the optimal software resource allocation. An important measure for software resource optimization is performance, mainly measured by the response time of the multi-tier web system. In this paper, the response time should be within an acceptable bound, that is, the response time RT should be less than a threshold (DRT). The process of decision-making for software resource allocation can be formulated as a micro-decision process, which consists of states, action, and rewards. A state is defined as a vector that includes the allocation of different software resources and the workload. There are three candidates for action selections in each tier of the system: increase, decrease, or keep. The action in tier I is described as AI. During each state transition, the reward is computed based on the response time and the software resource allocation in current state. The reward is denoted as RK, and different rewards are given according to different situations. Accordingly, we divided the reward into 4 levels. Then, in order to select the appropriate action for each software resource and obtain the optimized allocation based on the reward signals, we propose a deep Q-learning network based on solution approach. We expect to obtain the optimal action value function Q, which satisfies the following equation. We adopt a neural network that can estimate the action value function Q. The algorithm for software resource allocation optimization is shown in Algorithm 1. Detailed analysis can be found in our paper. Next is experimental measurements. I firstly introduce the experimental setup We use the root-based system as our testing environment. The root-based system is based on the property of eBay auction web service system and can be used to study the performance of multi-tier web service system. The system is implemented as 3 tiers, which are web server tier, application server tier, and database server tier, respectively. In each tier, software resource we select can be used to configure the number of threads or processes of the server. In our multi-tier systems, WL is as follows. We set the performance demands, response time, less than 1 second. The workload used in the experiments is shown as the figure. The change in workload reflects the dynamic, such as increase and decrease of workload. To evaluate the effectiveness of our iterative feedback mechanism, we trained it two SR predictors, SR predictor 1 shown in figure 5 and SR predictor 2 shown in figure 6. SR predictor 2 increases the amount of training data compared to SR predictor 1. As you can see, the increase in training data improves model performance and reduces the use of software resources. Figure 6 uses fewer software resources than Figure 5. This figure shows the comparison of response time by using the two software resource predictor. It can be observed in the figure that 3 experiments with SR predictor 1 do not meet the response time 1 second. They are concurrent users with workload of 5,300, 7,000, 8,200, respectively. By analyzing these experimental results, it can be observed that workloads not meeting the performance requirements with SR predictor 1 concentrate on the concurrent users with workloads greater than 5,000. This is due to the fact that most workload data in our dataset concentrate concurrent users with less than 5,000 tasks. Then we appropriately increase the concurrent users with workload of 5,000 in the 100 subsequently experiments. As shown in Figure 7, the addition of new data improves the usability of the method. Although there are still 2 experiments with SR predictor 2 whose response time does not meet the requirements, the effect of the updated predictor is still significantly improved. Above all, the effectiveness of the iterative feedback mechanism is validated by the experiment results. Final is the conclusion. Software resource allocation is critical to the performance of web systems. In order to cope with dynamic workloads and guarantee system performance, an iterative feedback mechanism, which includes data collection and pre-process, SR predictor, resource allocator, is proposed to optimize the allocation of software resource in different tiers of the multi-tier web systems. In data collection and pre-process module, it models the dynamic workload by semantic process and calculates the parameters. In SR predictor module, it applies the reinforcement learning approach to obtain the optimized software resource allocations. In resource allocator module, it adjusts the software resource allocations in the experiment and expanded the training dataset. These three modules enable the SR predictor to be iteratively updated and optimized. Based on the rule-based benchmark system, the effectiveness of the mechanism is experimentally validated in this paper. Thank you.